Read the problem carefully. Can't emphasize that enough. Often students will make mistakes like switching meters per second, which is a velocity term, and meters per second squared, which is acceleration. You can avoid these mistakes by reading carefully and taking your time while solving problems. Draw a sketch if necessary. Having a sketch can help with some problems, but it's not necessary for every problem. This step will be much more important next chapter when we get into dynamics. List the given variables, any appropriate constants, and the variable you're looking for. Knowing the units that go with each variable is a big help in knowing which variable is which, right? Because if you have meters per second, you know that's speed or velocity. Watch out for words like at rest, stationary, or comes to a stop. All of these are clues that either the initial or final velocity is zero. Objects that are dropped, if they say you drop something from a height or you drop it off a cliff, they have a zero initial velocity. Read carefully. There's that read carefully again. It keeps showing up. Look for words like from and to in order to help distinguish between initial, that would be from, and final, which would be to. Think to yourself, which one was first, which one was last? When an object is moving unsupported through the air, and that's in free fall, its acceleration is 9.8 meters per second squared downward. The only time you set acceleration equal to g, though, is when the object moves through the air. Select an appropriate equation to use. Here's our three kinematics equations, right here. First, second, and third. We see they all have different combinations of variables. Make a table, which we have done for you here, to organize the equations and variables. And the check mark means that that variable is in the equation. The X means it is not. Hopefully we can see that X and T are the most helpful variables to look at. Not every equation has an X or a T. Well, they also don't have a V here, but V and V0 can be confused. It is safer to look at X and T when choosing an equation. Okay, so let's get back up to the top. Just want to give that quick reminder. If your list of variables has T but not X, use the first equation, right here. If your list of variables has X but not T, use the last equation. This is the third kinematics. That comes in handy a lot of times. And do you remember how we found it? We combined the first and second equations and eliminated time. And hence, that's why there's no time there. If you have X and T, go ahead and use the middle equation. Once you have your equation, move it around to solve for the missing variable. Sometimes it might already be set up correctly, but do not plug in numbers right away. That's the last step. Finally, put the numbers in and solve for numerical answer. And check that you have what? The right units. When the equation is arranged correctly, then you can substitute in your values and solve for numerical answer. Keep an eye on your units, and don't forget to put units on your final answer. Constant velocity, what does that mean? It means the acceleration is equal to 0. So they may not say acceleration is 0, but once you see constant velocity, you make that leap right over to there. Constant acceleration is a trick. All of our problems so far have constant acceleration. This doesn't help you, that phrase, constant acceleration. However, in the future, in APC, you'll see problems where the acceleration is not constant. Don't get confused when you see constant acceleration.